warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
It's my great pleasure to guide us in this session. We have a special speaker who put a very big attention to mechanical research, especially human and machine interface. Let me introduce this our fabulous speaker to us. He is Professor Minoru Sasaki. Currently, he is a professor in Gifu University, Japan. Professor Minoru Sasaki was born 13 September 64 years ago. On the same day, Dr. Andus Muhammad Hatta, the Vice President of Indonesia, officially ran Universitas Andalas. He got his bachelor degree in Yamagata University on 1980. Then he got the bachelor and doctoral degree in Tohoku University on 1982 and 1985. Tohoku University located at Sendai City, Miyagi Prefecture. In his academic life, Professor Sasaki actually a professor in Gifu University, but he already built a long road in many institutions to do research and education. He started as assistant professor in Miyagi University, and he became visiting professor at California University and Georgia University. He is also a visiting professor in King Mongkut University. And finally, he has a very long story in Kenya. He already published many publications. Professor Minoru Sasaki runs some experiments in his laboratory. He already has many students from many countries. Now, personally, I know that his former students already spread around the world. Because of his dedication for engineering education in Kenya, he was awarded Doctor of Engineering honoris causa from Dedan Kimathi University of Technology. In his academic life, Professor Sasaki actually a professor in Gifu University. He also put a big attention for foreign students in Gifu University. He loved to join student activity who invite him. Today, finally, we will give the time for Professor Sasaki to give a talk. The title is Robot Control System Based on Electrooculography. Sasaki Sensei, the time is yours, please.
See this slide?
I can. Okay.
Okay.
Please.
Okay. I skipped. So I'd like first explain about major problems faced by Japan. So in Japan, aging population combined with diminishing number of children. So decreasing in the workforce and safe and pleasant life and convenient and affluent life. So you can see, sorry, or slide in Japanese. 2005 is about workforce population is about 61%, and elderly people's population about 20%. So that means supported one elderly people by 3.0 peoples. And on the other hand, 2030 is working force population number is decreasing and about 55%. And on the other hand, elder people over 65 years old is about 30%. It means one elderly people supported by the 1.86 people. So also the new affluent newborn rate is decreasing every year. So max is about 1949. About new baby was born 2.7 million, but current less than the 1 million, and so that is very problems. So now you can see the total fertility rate is this black line shows Japanese in Japan, and yellow line shows Koreans, and so most Asian countries going down. So, but I think in Indonesia, totally fertility rate is over 2 or 3 and increasing population. That is very nice. But in Japan, not so much working force, and so new baby was born. So also government think about how to actualize the nation based on creativity in science and technologies. So setting strategic priority and enhancing mutual cooperation of research and development projects. So active effort towards international standardization activities. So this budget related to international standardizations is 1.69 billion. So enhancement of technological transfer from universities. So budget related to research and development programs. So budget related to focus 21st centuries. So it's important fuel sectors and digital consumer electronics sectors, robot sector, and health and welfare sectors, and environment, energy sectors, nanotechnology, and material sectors. So most important is the robot sector and health and welfare sectors. So it's has a huge budget. So and enhancement and compatibility of the robot industry and social needs. So this is a technological strategies. So the robot becomes something familiar to a lot of use in life and public space. So enhancing and creative foreign generation market for industry service special environments. So strategy of acceleration of innovation and operation of robots. Introduce legislation towards safety aspect. So robot is an integrative technology system. Robot technology has a big spillover effect on medium and small companies.
Yeah.
So current state and trends of assistive technology industries. So number one, possibility of assistive technology industries. So increasing needs from welfare to well-being. So increasing the quality and efficiency from activity of daily living to quality of life. In 1990, United Nations decided principles for the elderly people, self-support, participation, care, and self-fulfillment duties. So urgent task of efficiency supply to products and service because of increasing of medical care expenditures, the elderly and welfare service for the elderly and decreasing the population of productive age. So this is a handicapped people in Japan's percentage. So over 50% crippled people, 26.2 the mentally retired, and 9.3 is a vision impaired, and something like that. So this is a requirement of welfare equipment. First is user friendliness. Second is safety. Third is cheap. Fourth is simple. Fifth is after sales service. So I would like to ask about potential of biopotential signal interface to welfare equipments. So qualitative evaluation method of human diversity. How to communicate between the machine and the human. And machine and robot has no sensor about communicate between humans. So that is also problems. So how to realize the borderless world, disabled and able persons. How to make an objective state estimation of the humans. So merit of physiologic bioinstrumentations. First is objectivity, second is quantifications, third is real-time operations, fourth is continuity, fifth is non-verbal, and sixth is vital function. So can we estimate and analyze the emotion of human by using the biopotential signals? So require technology of analysis and evaluations. So first is instrumentations, include electrodes, amplifiers, and frequency, and AD converters. Next is the signal processing method, analysis, spectral analysis, FFTs analysis, and wavelength analysis, and so on. So analysis, feature measurement, statistics analysis, multivariable analysis, etc. Also, it has a huge database. So biopotential signals include, for example, EOZ, EEGs, EMG, and the ECG, and neurological potentials. Sorry. So I'd like to show you some example of our previous research about pipe locomotion robot control using biopotential signals. We use simple biopotential measurement systems, like headband includes sensors, electrodes, and we can detect EMG, EOG, and EEG signals. So this system is easy to put on and take off. And so this is analysis of biopotential signals. We use a neural network for recognition of signals. So also experimental system is operator attach the sensor and send the data to the PC, and PC send to the robot control signal to, and then robot receive the control command. So this is an example of an experiment. Sorry, small robot is go forward and go backward, turn right and turn left. So also, I'd like to express emotion estimation by using brain waves. So this is a experience setup. This is a sensor helmet, and this is the analog digital conversion box, and this is a processor box, include the data filter, and finally the data to the PCs. So this is imagination and real data. So this is the colored map shows the imagine case of right hand moving. So this figure shows real right hand data, the brainwave mapping. So this is also imagine left hand and real left hand motions, and next real right toe moving, and imagine right toe moving, and also imagine left toe moving, and real left toe motions. So you can see the color difference. Blue shows not active, and green shows a bit more active than blue ones, and red shows more active than others. And you can see the mapping difference, and some part is colored red, but other case is blue and greens. So if we can identify these mapping difference, we can understand the human operators operations. So this is a function of cerebral cortex, and sensory mapping, and motor mapping. So you can see in case of motor cortex, huge areas shows face, but also hand area is big, but very small area related to the legs. So that means so we can operate, think about hand operation and face operation, but we are usually walking, but at this time we are not think about how to operate my legs and something like that. So this is a aspect part of the brains, right legs, left legs, and right hand, left hand. So that is a result of motion estimations rate, almost over the 70%, 80%, and 90%. So this is a motion estimated experiment. If robot detected the operator's motions, and robot moving same as operators. Oops, sorry. So you can see the same motion of robot and operators. So also the robot control needs not limited on-off control, but servo controls. So this is only 1 degree of right and left motions related to the eye movement. You can see this. So, but it's a original point is difficult to match, and some difference between the eyes motion and some motors motions. So this is not limited to 1 degree, it's extend to 2 degree systems. It says 1 to 3 and 1 gram, and please take care. So, and also the proposed EOG attachment method, and conventional method attached by electrodes, but it's every time change to the accuracy of the attachment point. But if making the like mask, and so after that, electrode position is fixed, and we can get data for the stabilized data. So this is a if EOZ used for robot operation, we can distinguish two methods. One is a gaze estimation control method. The other is gaze direction control method. So gaze estimation controls are developed by the Ilhamdi, Dr. Ilhamdi. He remains a great effort for this research. And so from EOZs, we estimated the eye position, and manipulators move to that estimated positions. And so also, but if use EOZs and only one plane motions, but if you change the side view and top views, we can use 3D realize of 3D motions. And also gaze direction control step by step by Amri, my previous doctor course students. He realized step by step. But think about for robot control, we need one more input for control the robot hand or something. And we utilize that to EMG sensor on the face, and we detect the EMG for controlling the robot hand. And so also we should improve the transformation method. You can remember, and this method is has a skew angle for related to the 4 sensors. But so we Ilhamdis developed a new method of transformation matrix to this compensate skew angles, and then finally the real coordination. Right, this is a improved method equation for transformations. So also this is a CD player control systems story in Japanese. You can see the 3 electrodes at the forehead. Sorry, limited time, I'll skip this. So also the also 3D coordinate positioning operation systems. Potential signals pointed out the desired position and move to the robot.
Dalam bahasa Indonesia.
So, also end of manipulators control via EOZs and upside, up and down, and right and left. So also this is two-dimensional control via EOGs. So EOG from estimated desired position and move to the manipulator to the operator's desired positions. So also this is a previous Ilhamdi's experiment. He extended to two-dimensional to three-dimensional from side view and top views. So also this is Armory's experiment. So step by step and down and down and down. And T-spite EMG related to the hand grasping and then up and up. And move to left and left, and then put the point. So also, this is a EMG control experiment. Attach the electrode to the hand and estimated arm motion to same motion to view the monitors. If replace this monitor to the real robot, and we can control the robot hand. So I would like to make a conclusion of my talk. So we can operate some machines and robots by using biopotential signals, especially the EOGs, from on-off control to sub-controls and on-demand controls. So how to distinguish malfunctions? So biopotential signals means we can usually come out these signals, and we should distinguish malfunctions. So we need a more basic knowledge about the biopotential signals and human motions and emotions. So future work is from implicit knowledge to cognitive knowledge. So we should apply to life support and well-being system, and also training system for artisans, and transmit traditional to postulates. So also Ilhamdi applied to this kind of biopotential signals to famous badminton player and beginners badminton players, and then how to learn from beginner to expert or something. So I would like to ask the final question. What's next from robot to cyborg? This is a famous movie of Firefox for robot airplanes, and this is a Japanese anime Cyborg 009, and so also RoboCop, and my girlfriend is Cyborg is Japanese movies. Thank you for your attention, and sorry, a lot of trouble happens. So thank you, Hamdi.
Thank you, Professor Sasaki. Very interesting talk, and we know that Japan face a struggle condition with aging society, and this situation happened also to the ASEAN country, but in Indonesia, at this time, we still have enough new baby born, but we don't know next time. I think almost all country will find the same situation. So potential is one of the another solution to help people with disable condition. So especially in this situation where people cannot touch each other to operate machine because of pandemic COVID-19, for sure that we need alternative methods to operate machine. So we will give a chance for participant if maybe someone has want to ask or discussion. We please participant in the room. We have more than 200 participants right now. If someone want to ask Professor Sasaki, please just active your speaker, your mic.
Morning, sir.
Good morning.
Yes, please.
Yeah.
Please your name and institution.
Yeah. Good morning, Pak Ilham. My name is
Yeah.
Asfi Fadli. My honor to meet you in this conference. Good morning, Mr.
Please.
Minoru. I'm very amazed with this technology since it would be appropriate solution for helping disabled or other solution other problem. My question is, what is about the safety of this technology for human? I saw in the video there was tools that stick in human head to move a robot or something. Is there electric signal that can impair the human head if applied in long duration?
So that is a very important point. So think about now the most of robot for industry used and not yet service robot, and that is low problems. So at first we should make liability law or something, right? And how to give the responsibility if happens accident or something. So same as autonomous car control or something. So after the making the legal problem, then we should also for example, the industrial robot is over the motor's output. So if personal user service robot is we now the limited output powers less than, for example, 30 watt. If robot touch the human beings or something, at this time no accident happens. It's soft touch or something. So you can see the Ilham's experiment. That robot is flexible. It's we think about service robot or welfare robot. It needs some robot is not rigid but flexibility.
Okay.
Is that okay?
Okay. I ever saw the Ilham innovation for wheelchair. Okay, thank you.
Thank you, Bapak Asfi Fadli from Universitas Indonesia, University of Indonesia.
Yes, Pak.
Okay, please.
I have question.
Please, Bapak Firman Ridwan, please.
Yes. Thank you for my opportunity to ask question. This research is very interesting actually. And we, as I saw in the video, when we control our mind, can we translate, like, translating the mind from, moving left and right? Is it possible, like, instead of changing, moving the video, we translate into sentence or word? For example, like robot arm, when we're thinking about moving the object from one to another, and then we translate into some, sentences instead. means this very important for someone who got for example, like who got stroke disease, and very difficult to saying something and just by thinking and translate into the sentence, and we know other people knows that what the victim thinking about, something like that.
So,
Can you catch my question?
yes, and so current situation of research biopotential signals has not so accuracies. So we need a more research about. I said to you from on-off control to the sub-control. Sub-control needs a more information to, so how fast or how long or something like that. It's need a more information. We can we should pick more information about for example brainwave and the EOG and the EMG, but EOG has a lot of possibility for more accuracy than other biopotential signals. So, for example, we sorry, we showed the result of two-dimensional control. It has a good accuracy, but a lot still lack of accuracy. We need more research for that situations. Is that
Okay.
right? Okay.
So the Bapak Firman Ridwan asked, instead of controlling a robot using our brain, is it possible to transfer our brain signal into text? So can we give information to people from our brain? So if we are thinking, the signal convert to text instead of moving robot.
So still a lot of people doing research about such kind of things, not yet realize such kind of situations. We should more research about such kind of things. Is that okay?
Thanks.
And also the another problem is using brain waves. Brain waves means it depends on individualities. So some people are different from their background. This time the brain waves different outcomes, and that is problems. So yeah. So if we read the same novels, but people think about the different feeling and the different emotions, that is problems also.
Okay. Because of time, we will give the last chance for participant. If you want to ask question or Harisan,
I have one.
I saw you. Harisan. Special guest from Kenya. Please ask your professor.
Okay, I just came in midway when Professor Sasaki was presenting. So, but it's the topic I think you are an expert in under the professor. So I'll not make a comment now. I'll just maybe join and listen. I don't know if the video is clear. I'm not very sure. I'm in office now.
Thank you for attending.
Thank you.
Okay, please another. Thank you, Harisan.
Thank you, Trihan.
Please,
I have
Mr.
one question, moderator.
Please, Prof. Please.
Prof. Tami.
Prof. Tami, yeah.
Prof. Sasaki.
Yes.
I think you are addressing very interesting global issues on aging, and you have highlighted the human interaction to be explored. Yeah, and in doing this, it requires, among other things, a lot of things. Among other things, it requires, for example, programming skill, graphical user interfacing. So now, my question is that in order to address these, what is the way forward in education? For example, if you could highlight in Japan, is there any changes or upgrade of the curriculums to kind of highlight the way forward along these lines?
Yeah, it's so not yet going ahead, but our laboratory tried to do STEM education, science, technology, and mathematical art and something. It's so maybe human beings education started to the making something, and but making something needs a lot of technology field. For example, mechanical, electrical, programming, and something like that, and also art and mathematics. And if through this education we can naturally get such kind of performance, but it takes a long time, and so also technological education needs a budget and money, and so how to keep that government should support this kind of education for next generation of technologies. If stopped and something wrong, we can not solve the population increasing elderly people, and also coronavirus and a lot of things. But if we have the creativity and the new technologies, and maybe we will be able to solve this kind of problem. Is that okay for?
Thank you. It's good. It's okay. It's good. It's okay.
Okay.
Thank you.
Thank you, Professor Nasir Tamin, one of our keynote speaker. Okay, Professor Sasaki Sensei. So, because of time, it's already 10:12 in Padang City now. So, thank you very much for your presentation. It's very nice and very interesting. We hope I'm sure the participant will get many knowledge, and I hope I know that you are open for this discussion outside this room for other. So thank you very much, and we will give the time for the committee again. Please, committee, I hand over this mic for you. Thank you, Sasaki Sensei.
I appreciate. Thank you.
Please, committee. Please, committee.